Nieuwe technieken en technologieën maken het mogelijk dat dingen steeds sneller, makkelijker en beter kunnen worden uitgevoerd. Hierdoor wordt het ook makkelijker om sommige lopende maatschappelijke problemen aan te pakken, zoals bijvoorbeeld duurzaamheidsproblemen.
Technology is developing very fast, and we are seeing all kind of possibilities with technology, particularly in robot technology. And robots can be used for automated processes and, for instance, on maintenance of aircraft. I'm Peter Boeing, CEO of XYREC.
We're in San Antonio, Texas, inside a hangar where we have the laser coating removal robot and a Boeing 727 aircraft, and this is our test and demonstration capability facility. So the robot has the ability to understand where it is within its work environment. We have a localization method that is based on reflective targets, where the robot essentially has like an indoor GPS solution that gives its precise position relative to the hangar as well as the aircraft itself. Once the robot knows where it is, it moves autonomously around the aircraft and it begins to systematically remove the paint or the coatings from all of the surfaces. Part of the process includes a 20 kilowatt laser that we can control precisely so that we can operate at the right parameters for a particular type of a substrate. So for example, for aluminum, we can be faster and more aggressive. For composite material, we can operate in a more delicate fashion. We do that through a closed loop vision system where we're continuously monitoring the surface and watching layer by layer to make sure that we're moving at the right process parameters, the speed, the standoff distance, and as well as also monitoring for temperature. I'm Paul Evans, and I'm the Director of the Manufacturing and Robotics Technologies Department at Southwest Research Institute. So part of our process, we also have done work where we start to evaluate the more delicate features or parts of the aircraft. So for example, a window, you may want to turn on and off the laser as you come across a window or a door seal. So we have capabilities to be monitoring for those kinds of things and then being able to turn on and off the laser accordingly. One of the things we focused on is increased efficiency. So our goal is to reduce the amount of time that it takes for an aircraft to be in a depaint facility. So take, for example, a wide-body aircraft or a large defense-style cargo plane. We can do better than a quarter of the time that it normally takes them to process an aircraft through the facility. So there's some key benefits to the laser coating removal process. One of them is the production time is faster, so there's more use of the hangar for actual paint stripping operations. The other is that there's no longer any chemical stripping or hand sanding, and that's a great improvement on operators and workers' health and safety.
Next to the benefits for the society, it provides also benefits for the environment and for the aircraft operators. Currently, the CO2 footprint is high of operating aircraft, and by using this robot, we reduced the CO2 footprint from one paint job from 40 tons to 14 tons. That's more than 60% reduction. Also, by using robots, the paint is less thick on the aircraft, and that reduces the weight of the aircraft, and that reduces also the CO2 footprint. The end result of all this robot technology is that we improve the environment, we reduce the health risk, and we also provide a benefit to aircraft operator in a faster process.